This is question 11 of the N25 marks. Without any further ado, let's get started. A1 is an easy question. You know that alpha and beta are roots of g of x equals 0. So alpha plus beta is equal to negative q, and alpha beta is equal to r. Very straightforward. Part 2. Be very organized with this. Show that f alpha, f beta is equal to this shenanigan on the right. I would argue it's easier to just bite the bullet. Expand and simplify. We want to express the entire thing in terms of alpha and beta, wherever possible. Let's see if there's any way we can group the terms. 1, 2, 3. Seems like that's the best we can do right now. So I'm gonna factor the alpha beta out. What can we do with the remaining terms? I'm gonna group those two together because we can factor the BC out and we are left with alpha plus beta. So that's lovely. I can then group those two terms together. And we have c squared. Looking at the form of the right hand side, we know that we're gonna have a c squared over here anyway. So it's totally fine. Okay. Alpha beta is equal to r. Alpha plus beta, that's negative q. Alpha squared plus beta squared, that is c times alpha plus beta squared minus 2 alpha beta. This is classic. Alpha plus beta, that is negative q squared, you get q squared. Alpha beta, that's r. So now we have to show that this is equivalent to that. So to start off, we'll group of the terms that would give c minus r squared together. And now we are going to group of the remaining terms together and taking the negative sign out. AKA, we're using the right hand side. We're using what we're asked to prove as a template for us to mimic our proof. I may have missed a negative sign somewhere. right here actually. And this should be alpha plus beta times b. So negative qb. So consequently, this term will also be minus rqb. This term would then be rqb. First three terms, that's c minus r squared. The remaining three terms, let's factor rb out for the first bracket and cq out for the second bracket. Et voila. That is your final answer. Part B. Hence, or otherwise, prove that if the two equations have a common root, then these three form a geometric sequence. So let the common root be alpha. So the roots of f are alpha and gamma, and the roots of g are alpha and beta. We need to show that these three terms form a geometric sequence. In other words, we want to prove that c minus r squared is equal to cq minus br, b minus q. So let's use Vieta's theorem on both equations. So we know that alpha plus gamma is negative b, alpha gamma is c. Alpha plus beta is negative q, alpha beta is r. Are there any way we can simplify this? C minus r. C minus r is alpha gamma minus alpha beta. Factorize wherever possible. We have this. CQ minus BR. CQ minus BR. What can we simplify? We can simplify alpha, beta, gamma. So we are left with this. Okay, we can see the various parts of our proof is coming along. B minus Q. B minus Q, that would be very convenient. Therefore, now we just naively plug into this. Left hand side, that will get us this expression. Right hand side, that will give us this guy. These two are equal. Therefore, left hand side is equal to the right hand side. We have finished the proof. Part C. show that the equation whose roots are beta and gamma is this mess over here. So, from the roots, how could we deduce the equation of the quadratic? This equation is essentially equal to x minus beta, x minus gamma. So we need to find an expression for beta gamma, and we need to find an expression for beta plus gamma. The coefficient of the term in x squared is 1. So in other words, we need to show that this guy is equal to minus b of our quadratic, and this guy is equal to c in our quadratic. How do we find beta gamma? The easiest way I can think of is doing something similar to what they have here. So we are kind of cheating the system here, right? We wish to show that beta gamma is equal to this guy. So let's say Q minus B. What does it give us? Q minus B, that is gamma minus beta. C minus R. C minus R, that is this guy. CR. We found this to be, no we didn't. CR, that's alpha squared beta gamma. And C plus R is equal to alpha times beta plus gamma. Okay, interesting. So, how do we get beta gamma from here? Let's just say, consider CR times Q minus B squared divided by C minus R squared. CR, Q minus B squared, C minus R squared. Those are equal. Those are equal. We are left with beta gamma. We also know that C plus R times Q minus B divided by C minus R. C plus R, Q minus B, C minus R. That will cancel out. That will cancel out. And we do have beta plus gamma. Therefore, x minus beta, x minus gamma is equal to x minus this shenanigan is equal to x squared minus this guy plus that guy equal to 0. And you're done. So if you're clever with your algebraic manipulations, this question will take 10-15 minutes. If you hit a dead end, which is the case for most students, it's very hard to get out of the mess.